some numerical problems based on the standard enthalpy of formation. Okay? Question number 1. Question number 1 is the enthalpy of combustion of ethanoic acid is given as follows. The reaction is CH3COOH liquid plus 2O2 gas give 2CO2 gas plus 2H2O liquid. Delta H in this case is minus 867.0 kilojoule per mole. If values of delta FH naught of CO2 and H2O liquid are minus 393.5 kilojoule per mole and minus 286.0 kilojoule per mole respectively, calculate the enthalpy of formation of ethanoic acid. Okay? This is the question. We have to find the enthalpy of formation of ethanoic acid. Now the solution. The solution is, you know that the equation is CH3COOH liquid plus 2O2 gas. This gave 2CO2 gas plus 2H2O liquid, and delta RH naught is equal to minus 867.0 kilojoule per mole. So we already know the formula that delta RH naught is equal to summation of the standard enthalpy of formation of the products minus summation of the standard enthalpy of formation of reactants. Okay, so in this case minus 867.0 is equal to 2 into minus, okay, this is 2 into enthalpy of formation of water plus 2 into enthalpy of formation of CO2 minus enthalpy of formation of acetic acid minus 2 into enthalpy of formation of water. Now the values are given, so you just substitute the value. So minus 867.0 is equal to 2 into minus 286.0 plus 2 into minus 393.5 minus delta FH naught is standard enthalpy of formation of acetic acid plus 2 into 0, because the enthalpy of formation of water is 0. So delta FH naught of acetic acid is equal to 867 minus 572 minus 787, and this comes to be minus 492.0 kilojoule per mole. So this is the answer, minus 492.0 kilojoule per mole. Question number 2. Question number 2 is calculate the standard enthalpy of formation of C2H4 gas from the following thermochemical equation. Equation is C2H4 gas plus 3O2 gas. This gives 2CO2 gas plus 2H2O gas, and delta H naught is equal to minus 1323 kilojoule. Given that delta FH naught of CO2 and H2O are minus 393.5 and minus 249 kilojoule per mole respectively. Solution. We already know that delta RH naught is equal to summation of delta FH naught of products minus summation of delta FH naught of reactants. So substituting the values, we get minus 1323 is equal to 2 into minus 393.5 plus 2 into minus 249.0 minus delta FH naught of C2H4 plus 0. And this comes to be minus 787 minus 498, okay, and then minus delta FH naught C2H4, and this is equal to minus 1285 minus delta FH naught C2H4. So delta FH naught of C2H4 is equal to 1323 minus 1285, that is plus 38 kilojoule per mole. Question 3. Calculate the enthalpy change in the reaction 4NH3 gas plus 3O2 gas give 2N2 gas plus 6H2O liquid. At 298 Kelvin, given that the enthalpy of formation at 298 Kelvin for NH3 gas and H2O liquid are minus 46.0 and minus 286.0 kilojoule per mole respectively. Okay, so here we have to calculate the enthalpy change in the reaction. Now you already know what is the formula. So the solution, you know that the standard enthalpy of reaction is equal to summation of standard enthalpy of formation of the products minus summation of standard enthalpy of the reactants. Okay. So here the equation is 4NH3 plus 3O2 gas gives 6H2O liquid plus 2N2 gas. Okay. So obviously delta RH naught is equal to summation of standard enthalpy of formation of products minus summation of standard enthalpy of formation of the reactant is equal to 6 times of water, 6 times 6 delta FH naught of water plus 2 times delta FH naught of N2 minus 4 times delta FH naught of NH3 plus 3 times delta FH naught of O2. Now the values are already given. Okay. So when the values are given, you simply you have to substitute the values. Okay. And the values in this case is delta RH naught is equal to 6 times 6 into minus 286 plus 2 into 0 minus 4 into minus 46 plus 3 into 0, and this comes to be minus 1716 plus 184. This is equal to minus 1532 kilojoule. This is very simple. You simply have to substitute the values which are already given and you will get the result. The question number 4 is calculate the enthalpy change for the reaction CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O gas, 2H2O liquid. The enthalpy of formation of CH4 gas, CO2 gas, H2O liquid are minus 74.8 kilojoule per mole, minus 393.5 kilojoule per mole, and minus 285.8 kilojoule per mole respectively. Okay, so the reaction is already given and you already know the formula. So delta RH naught is equal to summation of standard enthalpy of formation of the product minus summation of standard enthalpy of formation of the reactant. Here the values of CO2 and water are already given. So delta RH naught is equal to 2 times water. First CO2, that is minus 393.5 plus 2 times 2 into minus 285.8 minus 74.8 plus 2 into 0, and this is minus 965.1 plus 74.8, and this is equal to minus 890.3 kilojoule per mole. Okay, so the enthalpy change for the reaction is minus 890.3 kilojoule per mole.